In the third week of November 1944, at a command post somewhere east of Aachen, in what had recently been German-held territory, a signals officer attached to the 1st United States Army sat down with a captured German field radio and attempted to understand what he was holding. The man was not an engineer. He was a signals intelligence analyst whose name appears in the relevant Army records only as Lieutenant R. Harmon, and the notes he wrote that afternoon were forwarded up the chain of command and eventually incorporated into a technical assessment that was classified for more than a decade after the war ended. What he found when he examined the German radio surprised him, not because it was better than what his own men were carrying. It surprised him because it was worse, measurably, demonstrably, in almost every practical category that mattered on a battlefield, worse. This is a story that the history of the Second World War rarely tells in full. It is the story of how the German army, the army that entered the war with the most sophisticated signals doctrine in the world, the army whose radio-coordinated Blitzkrieg tactics in 1939 and 1940 had left every other military force on Earth scrambling to understand what had just happened to them, spent the last 3 years of that same war fighting with communications equipment that could not reliably do what American equipment could do as a matter of routine. It is also the story of why German commanders at every level, from division headquarters down to the individual tank crew, almost never understood the true nature of the gap they were operating across. This was because the gap had not existed at the beginning, by the time it became decisive. There was no longer any institutional mechanism inside the Wehrmacht that would permit anyone to say so clearly. The German radio advantage in 1939 was real, and it was substantial. The standard German tank radio of the invasion of Poland was the FUG-5, a frequency-modulated set operating in the 27 to 33 MHz range, with a reliable voice range of approximately 4 kilometers under field conditions. That was 4 kilometers more than most of the Polish and French armor that faced it could manage. French tank doctrine as late as 1940 still assumed that armored formations would receive orders by messenger or by flag signal. British equipment was marginally better, but still designed around a command philosophy that treated radio as an exceptional tool rather than a continuous operational one. The Germans had built their entire armored warfare concept around the assumption that every vehicle in a formation could speak to every other vehicle in real time. In 1940, that assumption was correct, and it was lethal. The men who studied the fall of France and tried to understand how an armored force of roughly equal size to the Allied one had cut through the Ardennes and reached the English Channel in 10 days came back to the radio question repeatedly. The tank itself was not the answer. The answer was what the tank crews could hear. What happened over the following 4 years is the part that requires careful attention. This was because it did not happen through German failure alone. The German signals industry did not collapse. German engineers did not stop working. The FUG series of radios continued to be developed and refined throughout the war. The sets that equipped late-war German armor were in several respects more technically sophisticated than the sets they replaced. The problem was not that German radio technology regressed. The problem was that American radio technology advanced at a rate and on a scale that the German signals establishment had not modeled as a possibility and had no institutional framework for tracking accurately once it began. The American radio industry in 1940 was the largest in the world, by a margin that had no meaningful parallel in any other military-industrial category. The United States had more licensed radio transmitters, more trained radio engineers, more manufacturing capacity dedicated to electronic components, more accumulated patent knowledge concentrated in commercially competitive firms than every other nation combined. RCA alone employed more electrical engineers than the entire German military signals research establishment. Motorola, which had spent the previous decade building car radios and portable civilian receivers. had developed manufacturing processes for ruggedized radio assemblies that were directly transferable to military applications, Galvin Manufacturing, which would later formalize as Motorola, had by 1940 already solved most of the practical engineering problems that German military radio designers were still treating as open research questions. The set that ultimately defined American tactical communications in the Second World War was the SCR-300, a frequency-modulated backpack transceiver developed by Galvin Manufacturing beginning in 1940 and fielded in significant numbers by 1943. It weighed approximately 35 pounds with battery. It operated in the 40 to 48 megahertz band. It provided reliable voice communication at ranges consistently exceeding 5 kilometers in average terrain, with demonstrated ranges of more than 15 kilometers under favorable conditions. Those figures were not exceptional in isolation. What made the SCR-300 strategically significant was not any single performance number but the combination of reliability, producibility. The frequency modulation architecture that made it almost entirely resistant to the kind of static and interference that plagued the amplitude-modulated sets that German units were still relying on in the same period. An FM receiver does not amplify noise the way an AM receiver does. When signal strength drops, an FM set does not gradually fill with static. It either works or it does not. And under the conditions it was designed for, the SCR-300 worked. The production figures tell the larger story in the way that production figures in this period always do. Between 1941 and 1945, American industry produced approximately 50,000 SCR-300 units. It produced more than 130,000 of the smaller SCR-536 handheld transceiver, the set that infantrymen carried in their breast pockets, and that became the direct technological ancestor of every handheld radio made in the following half-century. It produced more than 150,000 of the vehicular SCR-508 and SCR-528 sets that equipped American armored vehicles and gave tank commanders the same real-time communication architecture that had made the German Blitzkrieg possible, now operating at a level of audio clarity and interference resistance that German tank crews in their own vehicles could not match. The total American output of military radio equipment between 1942 and 1945 exceeded 35 million individual units of all types, a figure that included not only combat radios but the full range of navigational direction finding, electronic countermeasure equipment that the American military had integrated into its operational doctrine at every level. German military radio production over the same period was approximately 200,000 sets of all types for all services. That number is not a misprint. The production disparity between the two countries in this single category was on the order of 175 to 1. German commanders at the level of Army Group and above had access to signals intelligence summaries that touched on American communications capability. But those summaries were filtered through an analytical process that had serious structural limitations. The Wehrmacht signals intelligence apparatus, the Nachrichtentruppe, was experienced and technically competent at intercepting and decoding enemy transmissions. But it was not organized to produce systematic assessments of enemy equipment quality. It could tell a German commander what an American unit was saying. It was not designed to tell him how clearly they were saying it, at what range, or across what terrain. The qualitative gap between German and American field communications was therefore largely invisible to the men who most needed to understand it. This was because it expressed itself not in intercepted content, but in operational tempo. Operational tempo was attributed to other causes. What a German infantry officer in the Hürtgen forest, in late 1944, experienced as an inexplicable American ability to call artillery quickly and accurately onto German positions, to shift reserves before German counterattacks had fully developed, to coordinate flanking movements between units that appeared to have no line-of-sight contact with each other was in considerable part a function of communications architecture. American battalions spoke to their supporting artillery by radio in real time. American company commanders spoke to adjacent company commanders directly without routing requests through battalion headquarters. American forward observers carried radios that let them communicate simultaneously with multiple fire missions at different ranges, the coordination that looked from the German side of the line. Like superior tactical intuition or aggressive officer initiative was being enabled at the hardware level by equipment that German industry had not produced and German doctrine had not anticipated needing. The man most responsible for translating American radio manufacturing capacity into military doctrine was not a general and not a politician. His name was James D. O'Connell, and he had spent most of the 1930s as a signals officer in an army that had not yet decided what it thought radio was for. He became chief signal officer in 1947, after the war had ended. But the doctrinal work that shaped American communications practice during the fighting years had been developed by the Signal Corps under his predecessors, particularly Major General Harry Ingalls, who held the position from 1943 onward and who understood with unusual clarity that the question of how many radios American industry could produce was inseparable from the question of how American infantry would fight. Ingalls pushed for distribution of radio equipment down to the squad level at a time when German doctrine still treated radio as primarily a tool of regimental and battalion command. Implications of that difference played out in every engagement from Sicily to the Rhine. There was a 21-year-old corporal from western Ohio named Dale Ferris, who appears in the regimental history of the 30th Infantry Division in a passage describing an action near Mortain in August 1944. When German armored units made the last serious German counteroffensive attempt in Normandy. Ferris was a radio operator. When the German tanks came through the American lines and his company was cut off, he maintained communication with his regimental headquarters for 11 hours from a position that was, for most of that time, behind the German line of advance. The artillery that was called in on the basis of his transmissions helped break the German attack at a moment when German commanders believed they had achieved a penetration that the Americans could not answer. He did not know, had ni nas, reason to know, that the clarity of the signal he was maintaining over a distance and through terrain conditions that would have defeated most German field radio equipment of the same period was itself a variable in the outcome of the battle. The German technical assessments that survived from the last years of the war, the reports written by signals engineers and captured after 1945, show something that Speer would likely have recognized from his own experience with production numbers. The engineers understood that they were behind. Several of the documents explicitly acknowledge American FM radio superiority in the frequency ranges that mattered for ground force coordination. What the documents do not show is any serious plan for closing the gap. This was because by 1943 the gap had grown beyond what German signals production capacity could address within any realistic time frame. By 1944, the bombing of German industrial infrastructure had ensured that even the production capacity that existed was operating below its theoretica, ceiling. A German tank commander in the last year of the war was fighting with a radio that had been state-of-the-art in 1940 against American units equipped with technology that had been designed, produced, fielded in the intervening 4 years by an industrial system that the German General Staff had never modeled accurately and had no real basis for understanding.